Hello guys, and welcome back to another video. In today's video we'll be talking about data modeling, which is one of the subtopics of the KDD process. Data modeling. Now what do we understand by data modeling? Now as data analyst, you are someone, as I've also explained before, will be working with data almost 95% of the time. Now in the previous step of the KDD, we have spoken about acquiring knowledge or domain around a specific problem statement that you're trying to solve. And then we can look at the different data gathering. So we have already covered the different types of data gathering techniques in the previous videos. Then we looked at a bit of data cleaning, understood how data can actually be cleaned when we receive data from different sources, from APIs or through web scraping or through company data, and how we can actually clean that. So we have looked at the different ways to achieve that. Then we have looked at data pre-processing. Now within data pre-processing, we have discussed about feature construction, feature selection. What are the different ways to actually select right features for your data? Or if you're trying to do a multivariate analysis or a univariate analysis, then what type of filter selection method is more suitable for you? We have discussed about that as well. And today we'll be talking about data modeling. Now when we're working with data modeling, we're working with different problem statements. We have identified what type of a problem it is. Now there are various algorithms that are available that could be used, but you cannot use every single algorithm for every single problem. There are some algorithms which work better for some problem statements, and then there are some algorithms which work better for different types of problem statements. Now when you are doing modeling, you need to understand whether you're working with a supervised data set or an unsupervised data set. Now the characteristics of a supervised data set would be it would be structured in nature. Now when I say structure, it means that it would have tags, it would have a target variable, it would have names of columns, and etc. Now when we're working with unsupervised data set, it is often unstructured in nature, and in this type of data set the target variable is not given. So you have to find out the target variable by performing different cluster analysis to actually understand the relationship between different variables. So this is unstructured in nature, and supervised data set is usually structured in nature. When we are working with supervised, when we are working towards supervised learning, there are two types of problem statements that we can encounter when we're working towards it. We can enter into a categorical or a regression problem. Now categorical problem would usually have ones and zeros or yes or no's in the target variable. So in the target variable, categorical problems would usually have ones and zeros and yes and no's. And regression problems obviously would not have categorical variables, it would usually have numbers. Now I'll talk about when can you use categorical problems and how can you identify regression problems when you are given a specific data set. Now let's say if you're given an insurance data set, okay, and you have credit card default data. In this case you would have n number of variables and at the end you may have a variable called default, which would either be yes, no, yes, no for each row, and each row here would basically represent a customer in the data set. Now these type of problems are often categorized as categorical problems. Now categoricals are basically yes and no's, or ones and zeros, and etc. And this comes under the bubble of supervised learning. Now this was an example of a categorical problem. Now let's say if you're working, how would you identify a regression problem? Let's say you live in an area, let's say you live in London, and you want to predict house prices in London. Now again, you would be given a data set which would have a number of variable, variable 2, variable n, and then you would have a column which would be prices, and you would be given prices for different, let's say these are your areas. Let's say this is Brent, this is Harrow, this is let's say Uxbridge. Okay, now these are different variables, and then you're given a column for prices. Let's say the prices here is 130,000 on average. Here it can be, let's say 200,000, and you've been asked to predict the price for Uxbridge. Now when you're asked to predict numbers or predict prices or predict sales, this is to do with regression problems. So over here you would use an algorithm which deals with regression, mostly linear regression. And with your insurance data set, you can use decision tree algorithm. Now when you're dealing with your supervised learning, there will be two types of problem statements. There is categorical, or you can put this as classification problems, or there will be regression problems within supervised learning. Now if you are working on some sort of classification problem, then you can use these algorithms. You can use a k nearest neighbor, you can use decision trees, you can also use logistic regression, you can use support vector machine. Now when you're dealing with regression problems, you can use the following algorithms. You can use linear regression, or you can use polynomial regression. You can also use decision trees here, and you can also use random forest. Now I will go into detail about each and every single algorithm. I'll make separate videos for the different algorithms that are out there. I will try to cover the maths behind those algorithms, how those algorithms can be implemented. So I'll make separate video. For example, I'll make a video on decision trees algorithm where I'll talk about what decision trees are, how it works, and what is the math behind decision trees. Similarly, I'll talk about logistic regression, k nearest neighbor. So I'll be making a completely separate video for that. This video will just focus on identifying, if you are having a supervised machine learning problem, let's say you're given a supervised data set and you have a classification problem, then these are the algorithms you can use. Or if you have a regression problem, then these are the types of algorithms that can be implemented. So this was to do with the supervised learning. Now we'll cover unsupervised learning. Now when we're dealing with unsupervised learning, you need to understand that this is often unstructured in nature, and they have no labels when the data set's given to you. Now, what happens in unsupervised learning is that you are supposed to find out the target variable by yourself. Now, this can be done by performing different types of cluster analysis. You can do a different type of association analysis to find out the target variable. Now, within unsupervised learning, as supervised learning has two types of problem statements, regression and classification problems, the same way unsupervised learning also has different types of problem. They can have clustering and dimensionality reduction. This can be one of the problems, and the different algorithms that you can use within this is SVD, which is also known as singular value decomposition. Now SVD is a very popular algorithm that you used for recommendation systems. It is a type of matrix factorization algorithm, and it is widely used in movie recommendation systems, song recommendation systems, product recommendation systems. And the way it works is, it takes a given matrix R and it converts that into three small matrices. So what it tries to do is it tries to reduce the dimensionality of the given data set into three small matrices. So that is what a singular value decomposition does. Now another type of algorithm you can use is PCA, which is also known as principal component analysis. Now this is another type of dimensionality reduction technique that you can use to reduce the dimension of the data set. And the final one within this subcategory is k-means algorithm that you can also use. Another type of problem statement that you may identify in unsupervised learning, or you may approach, is association analysis. Now within association analysis, you can leverage the Fourier algorithm or the FP growth algorithm to execute the specific problem statement. I hope this gives you a better understanding of how and what to do when you reach the data modeling stage. One last point I would like to also add is, in terms of selecting which algorithm to use, you can use something known as a pair plot. Now what a pair plot is basically it shows the distribution of your data on an x and y plane, and it draws a line at 45 degree and it shows the distribution. Now if the data is distributed equally, which in 99% of the time it would not be the case, but hypothetically let's assume that the data is distributed 50-50, then you can identify what type of an algorithm to use. Now if you have data points all over the place, then with the help of Pairplot you can also identify that, okay, now because the data is distributed this way, I may let's say use a logistic regression, or I may use a linear regression to solve a specific problem. So pair plots do come in handy once you have identified whether it is a supervised machine learning problem or an unsupervised machine learning problem, and whether you have also further identified that whether it's a regression problem or whether it's a classification problem. Then you can construct a pair plot and you can basically get a better understanding of what type of algorithm would be best suited for the given modeling and for the given data set. Now, I hope this video was helpful. So take time to absorb all the information that's given here, and make sure you understand the difference between a supervised machine learning problem and an unsupervised machine learning problem. Make sure you are able to identify classification problems and regression problems and clustering problems, and your association problems. Now, this basically comes with practice. The more practice you have, the more data sets you work on, the better understanding you will have, and you will be better at identifying what type of a machine learning problem this is. So I hope this video helped everyone who wanted to know more about data modeling and what are the different steps that goes inside modeling and the algorithms that we use, how we decide on which algorithms to use. I hope this video was a value add to everyone, and do share this video, do give it a like. It really supports the channel. And if you have someone, if you know someone who's interested in these type of analytics videos, then do share this video with them as well. Till my next video, where I'll talk about model evaluation. Now, this video will probably come out on a Friday about model evaluation. So till then, I hope everybody has a great week ahead, and till then, keep learning. I'll see you guys in the next video. Thank you. Bye bye.